In the previous video of this project, we made the flywheel for the gyroscope. In this concluding episode, we made the axle, frame and bearings and give it all a run. Now we're going to start by making the axle, and much like the wheel, we'd like everything concentric when we finish with this part. So the way we hold the workpiece in the lathe is going to matter. You can hold the work in a collet and get it pretty close. Or if you have a four-jaw chuck, you can spend a bit of time with an indicator and get it even closer. Either way, we'd like to see the stock running as true as possible. If you only have a three-jaw chuck, you can get away with using that, but there'll be a small vibration when the gyroscope winds up to full speed. Once you're satisfied the stock is running true, set the compound to 30 degrees and taper cut each end of the rod. Okay, next set up the work on the mill so we can cross drill a small hole for the pull cord. You'll need to mill a small flat on the top before drilling to give the bit somewhere to start. And that's the axle done for now. Next we'll make the frame. And since it's quite a slender part, we're going to do most of the work while it's still attached to the parent stock. It'll make it more rigid and easier to hold. First, let's clean up each face on the lathe. And to do that, we need the tube running as true as we can get it. Now you can tap it true on the chuck to get it close, but here's a really simple tool that'll get you a great result. It makes use of an interesting property of the lathe, where the workpiece will naturally try to centre itself when it's touched by an external force. The work is lightly held by the chuck, and then a light touch with the bearing sets it true. Once it's running true, the chuck can be tightened. It's reasonably straightforward to make one of these centering tools, and I think well worth the time spent making it, because it'll help you to centre a lot of difficult workpieces in the future. Okay, so take a facing cut across one end and then remove the work and push that face up against the chuck jaws. With the other end face true, the workpiece can now be securely held in the vise on the mill. But before we head over to the mill, use a centre finding square to mark a reference line across the stock. We're going to use this line to help align the work as we drill and tap the holes. Use an edge finder to pick up the edge of the work and then drill the hole for the bottom bearing. Now rotate the work, align the reference line with the vise jaws and then drill and tap the hole to match the thread for the top bearing. Rechuck the part on the lathe, clean up all of the surfaces and then part off to the appropriate length. A quick rechuck the other way around and we can take care of the final facing cut and chamfer. Now let's take a look at the bearings. We're going to start with the unthreaded one first, so load the brass rod into the 3-jaw chuck and then reduce it to the correct diameter. And since we're about to form the inside bearing cone, now is a good time to talk about how these bearings actually work. It's a super simple idea. The point on the end of the axle sits in the base of the cone and it's essentially trapped. The only thing it can do is rotate. And because of the point contact, it experiences very low friction. Now typically a cone bearing like this would have a cup angle of about 80 degrees. But that would require us to make or buy a custom cutter, and I really want to avoid that if I can. So I've specified the cup angle to be 120 degrees. That way we can form the cup with a common drill bit like this. Now it means that the cup is quite shallow, so it's not as laterally stable as it could be, but I found it's quite okay for what we're doing here. So set up the tailstock for drilling and gently spot the end of the work. Give the work a light chamfer and then part off, flip the part and rechuck. Drill a hole in the other end to accept the extension rods later on. The threaded bearing is formed in a similar way, except before parting off, use a threading die to form the thread. Okay, now using a file or even a hacksaw blade, carefully form a small screwdriver slot. And we're on the home stretch now, with the final parts to be made being the base and the extension rods. The base is a reasonably simple piece of turning, with the cone shape formed with successively larger drill bits, and then all of the other surfaces faced and edges chamfered. Now to speed things along a little, off camera I made the pull cord using the string and wooden dowel, and I've trimmed the extension rods according to the plans. So with all of the parts complete, let's put this thing together and give it a run. Start by screwing in the top bearing. Now we need the axle to be centrally positioned within the frame, so put it into place and then insert the lower bearing. Once you've got the position right, a drop of Loctite will hold that lower bearing in place. Position the wheel on the axle and then put both within the frame. Move the wheel so that it has equal clearance on each side. As before, use a small drop of Loctite adjacent to the axle hole. And be sure to have the wheel exactly in the place that you want it before you add the glue. On a joint as close as this, the Loctite sets really fast. You can adjust the bearings to allow a little freedom, add a few drops of oil, and we're ready to give this thing a run. So after all of our hard work, here it is, the moment of truth. Now the nylon cord works great, but but I really wanted to see what sort of speed this thing was capable of, so I cranked up the air compressor to give it a bit of extra help. And wow, does this thing really start to perform once you get it on compressed air. I'm Chris from Clickspring. Thanks for watching. I'll catch you on the next video.
If you liked this video, subscribe to our channel or send us a comment on Facebook or Twitter. Be sure to check out our other project videos or visit us on makezine.com.